Hey chemistry students, this tutorial is going to focus on the relationship between moles and particles. So we're going to work through two types of questions. And the first one, we're going to go from from moles to particles. And the second one, we're going to go from particles to moles. And to do both of these problems, we're going to use this conversion factor. So 1 mole is equal to 6.02 times 10 to the 23rd particles. Now remember, particles are representative, so you'll see the word atoms used for elements, molecules for molecular compounds, and formula units for ionic compounds. So let's jump to it. So number one, how many molecules are in 3.6 mole? So first and foremost, we need to determine what it is that we're starting with. Our starting point is 3.6 mole. So I'm going to go ahead and write that down, 3.6 mole. I'm going to set up for a conversion factor, and I'm going to write out what it is that I'm asked to find. So I'm asked for the number of molecules, so I'm just going to write molecules. All right, my next step, I have to figure out how do I plug in my conversion factor to solve for what I want. So one way that we did this was we put the side of the conversion factor that we wanted on top. So I'm asked to solve for molecules. Well, a molecule is a type of particle, so I'm going to put this half on top. So 6.02 times 10 to the 23rd, and we'll even change it to molecules. Anytime you're dealing with a big number like this, go ahead and put it in parentheses and put the second half of the conversion factor, the 1 mole, on the bottom. So this is saying that in 1 mole, I have Avogadro's number of molecules. Another reason why I'm going to put mole on the bottom, I want mole and mole to cancel out. Now this becomes a calculator problem. So you're going to type in 3.6. You're going to multiply it by this number. Go ahead and put that in parentheses. So 3.6 times 6.02 times 10 to the 23rd. When I do that, I get 2.17, we'll round, times 10 to the 24th. Molecules are in 3.16 mole. All right, number 2. How many mole are in 1.36 times 10 to the 21st atoms? All right, so I'm starting off with atoms and I'm asked to go to mole. So I'm going to write down what I know, 1.36 times 10 to the 21st atoms, set up for a conversion factor, write what I want out at the end, so mole. Now I have to figure out how do I plug this conversion factor in to solve for what I want. I'm going to go ahead and put parentheses around this big number. Right? If I want mole in the end, I need to put that part on top. So I'm going to put 1 mole. I'm going to write the other half on the bottom. So 6.02 times 10 to the 23rd atoms. So atoms, atoms cancel. Now, when I plug this one into my calculator, it's going to be a little different. Remember, you're going to multiply everything across the top and then divide by everything on the bottom. So when I plug this in, it'll be 1.36 times 10 to the 21st divided by Avogadro's number. So let's plug that in and see what we get. 1.36 times 10 to the 21st divided by 6.02 times 10 to the 23rd. And when I do that for my mole, I get 0.0023 mole. All right, so we went through two different problems. One where you worked from molecules and you got you went from mole to molecules, and the second one we went from atoms to mole. So go ahead and try some more on your own in your practice packet and online on those starters and finishers. And as always, ask me questions along the way, but don't neglect to come back to this video.